So class, according to these questions, we are given a view with a radius of 20 cm. So the radius of the view is 20 cm. And then we apply a force of 5 Newton act on the view in the direction which is tangential to the view. So tangential to the view means it will be acting at an angle 90 degree with the radius, okay? So the view starts to rotate from rest. So from the keywords rest, we know that the initial angular velocity for the view will be 0 radian per second. So it rotates at a constant angular acceleration alpha, which is 4 radian per second squared, without any frictional force at the axis of rotations. So after time 2 seconds, we want to determine the angular velocity of the view. So this will be referred to the final angular velocity after 2 seconds. And then the angle turned through by the view. So the angle turned through by the view actually is referred to the angular displacement. Then question C, the torque that acts on the view. So we want to find what is the value of the torque acting on the view due to the force 5 Newton. Okay. Then the last question, the moment of inertia of the view about the axis of rotation. So the moment of inertia is represented by capital I. So we want to find the value of I. So we start to solve the question. So first, since we know that the initial angular velocity of the view and then the angular accelerations of the view, so after 2 seconds, how much is the final angular velocity? So how we are going to relate these 4 physical quantities? So we are going to refer to the kinematics equations for rotational motions. So we have omega equal to omega naught plus alpha t. So omega naught is 0. We start from rest. The angular acceleration is 4. The time taken is 2. So we will get the angular velocity after 2 seconds will be 8 radian per second. Then we move on to question B. To determine the angular displacement of the view after 2 seconds, then we might use equation theta equal to omega naught t plus half alpha t squared. So our initial angular velocity is 0. So we will be left with half. Our angular acceleration will be 4. The time taken is 2 seconds squared. So you may pause the video to do the calculations. So if you calculate correctly, you should get 8 radian. Okay, then question C, we proceed to question C. So what is the torque acting on the view? So we have the general equation to calculate torque. Torque is the magnitude of force applied multiplied with the distance of the force with the axis of rotation and sine theta, whereby the theta is the angle between the force and the distance. So if we refer back to the figure 6.7, so you will notice that this is the force that we apply and this is the axis of rotations. So how far is the force applied from axis of rotations? Distance of the force applied with the axis of rotations is corresponding to the radius of the view, 20 cm. So the angle between the distance from the axis of rotation and the force applied is 90 degree. So I have my force is 5 Newton. The distance from the axis of rotation 20 cm is 0.2 meter. And then the angle between the F and R is 90 degree. So do the calculation, we will get the value of torque should be 1 Newton meter. Question D, we want to find the moment of inertia of the view about the axis of rotation. So we might refer to the Newton's second law for rotational motion. The summation of torque will causes angular accelerations. So whereby we have summation torque equal to I alpha. So the resultant torque here is due to the force applied. So the value will be 1 Newton meter. So we want to determine the value of I, and the angular accelerations for the wheel is 4 radian per second squared. So we do the calculations, we will get the moment of inertia should be 0.25, and the unit for moment of inertia will be kg meter squared.